So let's look at some problems on binomial theorem. The first one goes like this. The n plus 1 term from the end in the expansion of x minus 1 by x raised to the power 3n is 3n cn x power minus n minus 1 power n 3n cn x power minus n 3n cn x power n. Fourth option, minus 1 power n into 3n cn x power n. Now let us note that in this problem we use this fact. Rth term from end is n minus r plus 2 term from left side, term from beginning. For example, let us see here. Suppose you have an expansion x plus a power 5 example. Now it has 6 terms: t1, t2, t3, t4, t5, t6. What is n here? N is equal to 5. Suppose I say third term from right, end, term from end. What is the third term from the end? Observe that this is the first term, second term and third term. So that is, it's actually t4. Okay, so third term from end, as we see, let's go by this formula. It is t5 minus, what is r? 3 plus 2. That's nothing but t4. So this is an illustration to say that rth term from the end is nothing but n minus r plus 2th term from the beginning. This is the n minus r plus 2th term from the beginning here. Okay, here. So let's move on to the problem now. So as we said, the rth term from the end is nothing but the n minus r plus 2th term from the beginning here. What is in the expansion of x minus 1 by x to the power 3n we are to look at. In place of r we have n plus 1 and in place of n we have 3n. Now rth term from end we know is n minus r plus 2th term, tn minus r plus 2. So what is in place of r? In place of r we have n plus 1 and what do we have in place of n? 3n. So that makes it t3n minus n plus 1 plus 2 minus of n plus 1 plus 2. So that makes it 3n minus n, that is 2n, and then here we have minus 2 minus 1, that makes it plus 1. It is 2n plus 1th term in the expansion here. What is that going to be? 3n c 2n into x power n, x power 3n minus 2n, that into minus 1 by x power n. Okay, so that makes it, what is this? We can write this as 3n. This 3n c 2n can be written as 3n cn because we know that ncr is equal to ncn minus r. So using this identity, so 3n cn can be replaced by 3n cn c 2n and they are one and the same. So we can replace it. And what do you have here? X power n into minus 1 by n minus 1 power n by x power n. Okay, now this x power n and this x power n, we have here 1 by x power 2n here. That makes it 2n here. So that makes it 3n cn. So, and we have an x power 2n, we have an x power n here. So 3n cn 2n x power minus n. Okay, let's move on to the next question. It is an assertion reasoning type. Assertion A, the number of terms in the expansion of x plus y plus z power 5 is 21. Reason, the number of terms in the expansion of x plus y plus z to the power n is n plus 2c2. First option says both A and R are true and R is the correct explanation of A. Second option says both A and R are true but R is not the correct explanation of A. Third option says A is true but R is false. Fourth option, A is false but R is true. Now, here let us look at a result like this. x1 plus x2 plus so on xt power n. Now this is called a multinomial expansion here. This is given by summation n factorial by q1 factorial into q2 factorial into so on qt factorial. x1 raised to the power q1, x2 raised to the power q2, so on xt raised to the power qt. xt raised to the power qt, with this terms ranging over all possible solutions of q1 plus q2 plus qt equal to n. That is, what you do is, corresponding to each way you split qi's being non-negative integers, qi is integers. So for every splitting of this n into t non-negative numbers, you get a term here, and the coefficient will be given by n factorial by q1 factorial into q2 factorial into qt factorial. Now, how many distinct terms are here? As many as the number of solutions of this. The number of distinct terms in this expansion will be the number of distinct terms in the expansion is equal to the number of integer solutions of this equation q1 plus q2 plus so on qt equal to n. All qi's being non-negative here. And what is that given by? It's given by number of unknowns, that is, how many unknowns are there? T, so that minus 1 plus whatever you have on the right hand side plus C, choose t minus 1. Okay, this is the formula for it. What is the formula? The number of distinct terms in the expansion is equal to how many terms this summation ranges. As you keep changing q1, q2, qt, whose sum is equal to n and the qi's are non-negative integers, for every such splitting of n we have a term. So as many splittings as you have of n, that many terms will be possible, and this is the formula here, that is n plus t minus 1 c t minus 1. So that's the formula here. Now let's go back to the problem. The problem says the number of terms in the expansion of x plus y plus z to the power 5. Okay, this was the problem. Now what is in place of n? N is 5. What is in place of t? 3. How many terms, how many literals or how many symbols are involved? 3 symbols are involved. Okay, so now let's use that formula, number of distinct terms. T minus 1, that is 3 minus 1 plus 5 c 3 minus 1. How much does that make it? 7c2. What is 7c2? 21. So the answer is clearly the answer is 1. Okay, n plus 2c2, that is clearly n plus 2c2, 5 plus 2c2 here, right? If it is power n, it would have been n minus 1 plus 3, that makes it, okay, n plus 2 c2 there. So that's correct. So answer is So both A and R are correct, and R is in fact the correct explanation for A. So the correct option is 1. Let's move to the next question. The greatest binomial coefficients in the expansion of x power 3 by 2 into y by 2 plus 2 by x power x into y power 3 by 2 whole raised to the power 12 is 12c5, 12c6, third 12c5 into 2 square, fourth option 12c6 into 2 cube. Now let's look at this. First, x plus a power n, if you consider this binomial expansion, we know that it is in the form of NCR into x power n minus r into a power r ranging from 0 to n. These coefficients, NCRs, these are called the binomial coefficients. These are binomial coefficients. It's a fact that the binomial coefficients keep increasing, NC0 less than NC1, so on, NC2, so on, and the maximum binomial coefficient will be that which is NC n by 2 if n is even. That will be the maximum. Again, there will be reversal, n by 2 plus 1, so on, NCn. So this will be the maximum if n is even. For example, suppose your n is 4. So then 4C0, 4C1, 4C2, if you look at this 4C3 and 4C4. 4C0 is same as 4C4, 4C1 is same as 4C3, and you know that these two, this is 1 and this is 1, this is 4, this is 4, and 4C2 is 6 there. So you do find that this 4C2 is the largest. This is the largest. What if n is odd? Let's see here. Suppose n is 5. For example, n is 5. 5C0, 5C1, 5C2, 5C3. Look at this binomial coefficient. 5C4, 5C5. We know that NCR is equal to NCn minus R. So this is, these two are same, these two are same, and these two are same. We have 5C0 less than 5C1, that is less than 5C2, and this is less than, these two are equal. So we have two binomial coefficients which are maximum, greatest binomial coefficients here. So what is that? If NC n minus 1 by 2, which is equal to NC n plus 1 by 2, both are greatest binomial coefficients. Greatest binomial coefficients. In the case of n is odd, n odd. If n is odd. If n is even, we said NC n by 2 will be the unique largest binomial coefficient here. So we use this fact here. So now it has nothing to do with x and a. We are not asking for a general coefficient of a particular term. So we are only asking for the greatest binomial coefficient here. So it's clearly n here in our expansion is 12. In that expansion, something plus something. Okay, we have x power 3 by 2 into y by some 2 plus 2 by x into y power 3 by 2 raised to the power 12. This is what we had. Clearly n is 12, that is even number, which means that what's the rule that we have to apply? NC n by 2 will be the numeric greatest binomial coefficient. So greatest binomial coefficient is 12C6 there, 12C6. So what is the answer? The answer is 2. So let's move on to the next question, question number 4. If the coefficient of x power 7 in the expansion ax square plus 1 plus plus 1 by bx raised to the power 11 is equal to the coefficient of x power minus 7 in the expansion of ax minus 1 by bx square raised to the power 11. Then ab is equal to minus 1, a is equal to b, ab is equal to 1, a plus b is equal to 0. Let's look at this thing. We have two expansions, ax square plus 1 by bx raised to the power 11. What is this? This we can write it in the form of 11cr into ax square raised to the power 11 minus r into 1 by bx raised to the power r ranging from 0 to 11. Okay. Now, what is that term? We'll just club the power of x here. 11cr into a power of 11 minus r by b power r. Let's look at the coefficient. Remove the coefficient one place, and here we have club the x terms, x power 22 minus 2r here and x power minus r, so that makes it 22 minus 3r. Sigma r ranging from 0 to 11. That's the expansion there. Okay. Now, we are interested in the coefficient of x power 7 in this. Coefficient of x power 7 in this expansion. That means this 22 minus r must be made 7. That is 22 minus r, 3r should be made 7. So what is 3r then? 3r will be 22 minus 7, that is, which implies r has to be 5. So we have to look for the coefficient when r is equal to 5. So what is it? It becomes 11c5. The coefficient is 11c5, a power 11 minus 5, that is a power 6, by b power 5 is the coefficient of x power 7 in this expansion. Similarly, we will look at the expansion ax minus 1 by bx square raised to the power 11. Again, that is in the form of sigma r ranging from 0 to 11, 11cr ax raised to the power 11 minus r into minus 1 by bx square raised to the power r here. So now when I group the coefficient part one place and then the power of x term the other side, so we'll have r ranging from 0 to 11, 11cr a power 11 minus r, okay, by b power r into minus 1 power r here, okay, and then here we have x power 11 minus r minus 2r, so 11 minus 3r it makes it, minus 3r. What are we interested in? In this we are interested in the coefficient of x power minus 7. So coefficient of x power minus 7 here. In this, coefficient of x power minus 7 is what we are interested in this expansion. So what is it? In this, I need r to be equal to, I need 11 minus 3r to be equal to minus 7. So we need 11 minus 3r to be equal to minus 7. So that makes 3r to be 11 plus 7. That makes r to be equal to 6. R is 6. So I need to substitute r equals to 6 here and then find the coefficient. So what is that? 11c6. The coefficient is coefficient of x power minus 7 in the second expansion. In expansion 2 is 11c6 into a power, now what do we have? 11 minus 6, that is a power 5 by b power 6 into minus 1 power 6. What is minus 1 power 6 anyway? Plus 1 there. So it becomes 11c6 into a power 5 by b power 6 here, b power 6. Now these two have to be same. These two are equal. He says these two are equal. When are these two equal? Clearly. So that means we should have 11c6 is same as 11c5. Let's cancel that out. So what is it? A power 5 by b power 6 must be equal to a power 6 by b power 5. So what do we have here? A power 6 by b power 5. So that makes it a here. We cancel out. And we have a b here. B here. And then, so what do we have? AB to be equal to 1. So the answer is 3. Now let's move on to the next question. If x minus 2 raised to the power 100 is equal to summation sigma r ranging from 0 to 100 ar x power r, then a1 plus 2a2 plus 3a3 so on up to 100 into a100 is equal to first option 100, second option minus 100, third option 1 and fourth option 101. Now x minus 2 raised to the power 100. Now clearly this will be a 100th degree polynomial in x. So that's what has been written here. Right hand side has been written as sigma ar x power r ranging from 0 to 100. 0 to 100. Now what you want is not just the sum of the coefficients. How will I get the sum of the coefficients? If I want sum of the coefficients, I could have put x equal to 1, then that will be suppressed. I will have got sigma ar to be 1 minus 2 power 100. But we are interested in r into ar summation. So what we do is we differentiate both sides with respect to x. With respect to x. What if you differentiate? What do we get here? 100 into x minus 2 raised to the power 99. And what do we have on the right hand side? Derivative of sum of functions is sum of the derivatives. So we can actually take the summation and derivative inside the summation. So here we have r into ar into x power r minus 1. Actually, if you observe here, first term will be a constant a naught a1x plus a2x square plus so on so forth a100 x power 100. The first term is a clear constant, but the derivative of the first term will be 0. So I need not have to take the summation from 0, we'll take it from 1 to 100. Okay, now I want the summation. What is this? When I put r equal to 1, I have a1 into a1 into x power 0, 2 into a2 into x power 1, so on 100 into a100 into x power 99. This is your 100 into x minus 2 raised to the power 99. So we have 100 into x minus 2 raised to the power 99 equal to 1 into a1 into x power 0, 2 into a2 into x power 1, so on 100 into a100 into x power 99 there. Now observe, what we wanted was only the sum of the coefficients here. What we do is we put x equal to 1 both sides. Put x equal to 1 both sides, so that all these x terms will be suppressed. And we have here 100 into minus 1 power 99. That is equal to a1 plus 2 into a2 plus 3 into a3, so on 100 into a100. Now this is what we wanted actually. So what is that coming out to be? Minus 1 power 99 is anyway minus 1. So what we have here is minus 100. Therefore the answer is 2. The coefficient of x power 5 in the expansion of 1 plus x power 10 into 1 plus 1 by x raised to the power 20 is 30c5, 10c5, 20c5, 30c20. Let's go about how to do this problem here. 1 plus 1 by x raised to the power 20 here. In this product, we are interested in the coefficient of x power 5. Now, can we club these two into one binomial expansion? Let's see. we can rewrite this in the form of second expansion. We can write it in the form of x plus 1 raised to the power 20 divided by x power 20. Here we have 1 plus x power 10. I am just carrying this as it is. So what we have here is, I can even rewrite this as 1 plus x power 30 divided by x power 20. Now in this we are interested in the coefficient of x power 5. Coefficient of x power 5. Now what should I do? I am dividing each term with x power 20. So where will I get the x power 5 term? When in the numerator, so we have to pick up the coefficient of x power 25 in the numerator. That is, because you are dividing by x power 20, you pick up the term containing x power 25, then x power 25 by x power 20 will give me that x power 5. So I have to pick up the coefficient of x power 25 in the numerator. What is the coefficient of x power 25 in the numerator? Clearly 30c25. We know that 1 plus x power n has an expansion sigma NCR into x power r ranging from 0 to n. So now if this is the formula, binomial theorem formula. In this we are interested in, let us say n is here 30 and we are interested in r is equal to 25. So 30c 25. But we know that NCR is same as NCn minus r. So NCR is same as NCn minus r. We can use this here. So therefore 30c25 we can as well write it as 30c5. Therefore the answer is 1 there. Let's move on to the next question. The coefficient of x power 9 in the expansion 1 plus 9x plus 27x square plus 27x cube raised to the power 6 is 18c9 3 power 9. Second option 18c8 3 power 9. Third option 18c10 3 power 8. And fourth option 18c9 3 power 7. So then now let's see 1 plus 9x plus 27x square plus 27x cube. On the face of it, it appears to be a multinomial expansion, but we can bring it into a binomial. That is, we can condense this into an expansion containing only two symbols. So how do I do that? Observe that this 1 plus 9x plus 27x square plus 27x cube, we can write it in the form of 1 plus 3c1 into 3x plus 3c2 into 3x whole square. 3c2 is 3. So 9x square. 3 into 9x square will make it 27x square there. And we have here 3c3 into 3x whole cube. So this part inside the bracket is appearing to be like this. And now this is clearly 1 plus 3x raised to the power 3. So what does that entire expression become now? This expression becomes 1 plus 3x raised to the power 3 whole power 6. That makes it 1 plus 3x power 18. Okay. So using this fact that the base here can be represented as a binomial expansion 1 plus 3x power 3, I put it back here. I found that it is in the form of 1 plus 3x power 18. Now this is a binomial expansion, and in that what are we interested in? We are interested in the coefficient of x power 9. So coefficient of x power 9 here, of x power 9 here is, what is that? 18c9 into 3 power 9, because you will get this x power 9 will come with this 3, because x and 3, x is not a separate symbol, it is associated with 3 there. So 3x raised to the power 9 is what is the term that I will be getting, but we are interested in the coefficient, so it is 18c9 into 3 power 9. So the answer is clearly 1. Let's move on to the next question. If the coefficient of x in the expansion 1 plus ax raised to the power 8 into 1 plus 3x raised to the power 4 minus 1 plus x whole cube into 1 plus 2x raised to the power 4 is 0, then a value is 1 by 4, second option minus 1 by 4, third option 1 by 8, fourth option being minus 1 by 8. Here 1 plus ax raised to the power 8 into 1 plus 3x raised to the power 4 minus 1 plus x whole cube into 1 plus 2x raised to the power 4. This is the term in which I have to pick up coefficient of x and equate that to 0. Now first what we'll do is we'll pick up the coefficient of x power 1 from here. The coefficient of x. When you multiply, this is a polynomial of 8th degree, this is another polynomial of 4th degree. So how do you think we can get an x term? You take a constant from here. So x power 0 term from the first. There are two factors, x power 0 term from here and x power 1 term from here. Or you take x power 1 term from here and x power 0 term from here. These are the two ways we can extract x power 1 term in the product of two expansions. So what is it? Now this x power 0 term comes with what coefficient here? 8c0. And x power 1 term comes with what coefficient? 4c1 into, but this x will not come as it is, it comes with a 3. So we have a 4c1 into 3 there. So that is 12. So what is the coefficient of x power 1 obtained this way? This 8c0 is 1, 4c1 into 3 is 12, so this is 12. What is the coefficient of x in the first expansion? In the first expansion, the coefficient of x is 8c1 into a. So 8c1 into a. Okay. Next, what's the coefficient of x power 0 here? 4c0. 4c0 is anyway 1 here. So what we have is 8c1 is 8a and 4c0 is 1. So 8a into 1, that makes it 8a. Now either this way or this way, when you group the terms, that coefficient will be 12 plus 8a. So the coefficient of x power 1 in this product will be 12 plus 8a. Okay, so that's about the first part of it. Again, look at the second part here. Again, this has two parts. It's a product of two expansions, 1 plus x whole cube and 1 plus x to x power 4. What is the coefficient of x power 0 here? X power 0 coefficient comes with, this is 3c0. And what about the coefficient of x power 1 here? X power 1 coefficient is 4c1 into 2. So what is the product? Product gives me, here the product is giving me 3c0 1, 4c1 into 2, 8. Okay, so 8 is the coefficient of x power 1 obtained this way. So 8 into x power 1, I'll have the coefficient. We are only picking up the coefficient. The coefficient. Here. Next, I pick up x power 1 term from here and x power 0 term from here. So 3c1 into x power 1 into, come on, 4c0 into x power 0. So that makes it, what is that? 3c1 is 3 into 1, so that is 3. The total is 11. So what did you obtain the coefficient of x in this part? 12 plus 8a. So 12 plus 8a, and what was the coefficient of x here? 11. So 12 plus 8a minus 11 was given to be 0. So what is your 8a? 8a is equal to minus 1. So this implies a is equal to minus 1 by 8. Therefore, the option is 4. Let's move on to the next question. The term independent of x in the expansion under root of x by 3 plus root 3 by 2x square raised to the power 10 is 10c1, second option 5 by 12, third option 1, fourth option 32. Now we have the expansion under root of x by 3 plus root 3 by 2x square, whole thing raised to the power 10. Now we are interested in the term independent of x. That means we are interested in coefficient of x power 0 is the term independent of x. Independent of x. So this has to be borne in mind. In an expansion like this, if I am interested in the coefficient of x power 0, that means that is nothing but the term independent of x. Okay, here. Now, what's the general term? Now, which is the term that is giving the coefficient of x power 0? So, let's look at that. What's the general term? TR plus 1 is given by 10CR into first symbol raised to the power 10 minus r. So, root of x by 3, root x by 3 raised to the power 10 minus r. And second symbol raised to the power, that is root 3 by 2x square raised to the power r. That is the r plus 1 the term. Now let us group the x terms. So we have here, and the other coefficient part, let's separate out. So what do we have? 10CR, and here 1 by 3 power 10 minus r by 2, because root 3 can be written as 1 by 3 power half, 3 power half raised to the power 10 minus r, 3 power of 10 minus r by 2. And what we have here? 3 power r by 2. Okay. And now, and by 2 power r. Now let's group the x power terms. X power 10 minus r by 2. 10 minus r, root x raised to the power 10 minus r will be x power 10 minus r by 2. And now here x square is in the denominator. When raised to the numerator, it is x power minus 2. X power minus 2 raised to the power r will be minus 2r there. So that will club it here. Now, what is the r for which this part becomes 0? That's what we have to look at. And then that value of r will be substituted here. Then you get the term independent of x. Okay, now observe what do we have here? 10 minus r minus 4r by 2 should be equated to 0. By taking the LCM, we have this right here. So what do we have? 10 minus 5r to be 0. So clearly r is equal to 2. So r has to be 2 here. If r is equal to 2, what does this turn out to be? 10C2 into 1 by 3 power. What do we have here? 10 minus r, that is 8. 8 by 2, that is 4. 3 power r by 2 will make it 3 power 1 here. By 2 power 2. Okay, this is what we have here. And after simplification, let's see what this turns out to be. What is this? 10 into 10C2 is 10 into 9 by 2. And we have here 1 3 cancels here. So we have 3 cube. And we have here 1 by 3 cube into 2 square. So again, this we can write 5. And there is a 3 cube and 3 square here. So that makes it 3 here. So 5 by 3 into 2 square, that's what remains here. That's 5 by 12. The answer is 5 by 12. Okay. So that is it. Answer is 5 by 12, and that comes in the option 2. So answer is 5 by 12. Let's move on to the next problem. In the expansion of a plus b power n, the ratio of the binomial coefficients of second and third term is equal to the ratio of the binomial coefficients of fifth and fourth terms. Then what should be the value of n? N is 4, 5 or 6 or 7. So the options are 4, 5 or 6 or 7. Here let's make a note of this. A plus b power n, it has an expansion NCR, a power n minus r, b power r ranging from 0 to n. Now what is the second term? T2 will have the binomial coefficient as NC1. Coefficient in T2, binomial coefficient in T2. And binomial coefficient in T3. What is the binomial coefficient in T3? That is NC2. Okay. He says NC1 by NC2 is equal to the ratio of the binomial coefficients of the fifth and fourth term. So that is, what is the ratio of binomial coefficient of fifth term then? NC4 divided by NC3 there. This is what is given. Now, NC1 by NC2 is equal to NC4 by NC3. Now let us keep one thing in mind. We have a small result, NCR by NCR minus 1 is equal to n minus r plus 1 by r. So whenever the suffixes, superfixes are same and the suffixes are differing by 1, numerator suffix is 1 more than the denominator suffix. So we have this form. And if it were to be reverse, okay, if it were to be reverse here, I would have got, now here we have NC1 by NC2. So what is NCR minus 1 by NCR? R by n minus r plus 1. Okay, so here I can treat that r is equal to 2 in this case. Let us look at the left hand side. R is 2 here. So 2 by n minus 2 plus 1. That is 2 by n minus 1. And coming to this, what is r in this case? NCR by NCR minus 1, it is in that form, the first form. So r is equal to 4 here. So what do we have? N minus 4 plus 1 by 4 there. So what is this now? 2 by n minus 1 is equal to n minus 3 by 4. Okay. So we have here, therefore cross multiplying, we have n square minus 4n plus 3 is equal to 8. So what do we have here? N square minus 4n minus 5 is equal to 0. So that's clearly, we can factor it out as n minus 5 into n plus 1 is equal to 0. N cannot be negative, so n plus 1 is not equal to 0. Therefore what can be possible? N has to be equal to 5 there. And clearly the option is what? Answer is 2 there. So let's move on to the next question. The ratio of the coefficient of r plus 1th term in the expansion of 1 plus x power n plus 1 to the sum of the coefficients of rth and r plus 1th terms in the expansion of 1 plus x power n is 1 is to 1, 1 is to 2, 2 is to 1 and 1 is to 4. Now let us look at the expansion 1 plus x power n plus 1. What is r plus 1th term in this? Tr plus 1 here is given by n plus 1 Cr x power r. And what is the coefficient here? N plus 1 Cr. That's the coefficient. Now let us look at the expansion 1 plus x power n. He says the coefficient of x power r and coefficient of rth term and coefficient of r plus 1th term there. So Tr, what is the Tr coefficient? NCr minus 1 into x power r minus 1. This is the coefficient. Now NCr minus 1. Again look at Tr plus 1. What is the coefficient of Tr plus 1? NCr into x power r. He says we have to take the ratio of the coefficient of r plus 1th term in this expansion, and the sum of these coefficients, that is what we need to take. So, n plus 1 CR divided by NCR plus NCR minus 1. Now, here we have to bear one thing in mind. We have what is called a Pascal's identity with binomial coefficients. Pascal's identity with binomial coefficients. That is, NCR plus NCR minus 1 is given by n plus 1 CR. This is an important identity that you need to remember. Here NCR plus NCR minus 1 is equal to n plus 1 CR. Observe that when the suffixes are one and the same, suffixes differ by 1, the greater of the suffix comes here, and this superfix will be enhanced by 1. So, instead of n we will have n plus 1. Of these two, which is the maximum? R. So, that will come here. That is, but of course, these suffixes should differ only by 1 there. So, NCR plus NCR minus 1 is equal to n plus 1 CR. Here, an interesting combinatorial argument can be given to this here. Suppose there are n plus 1 persons, and you are choosing r persons out of them. So, the number of ways to do that is n plus 1 CR. Now, that can be done in this way. Suppose one of the persons is to be taken is a different person. I mean, he has a hat on him. So, in every R combination, we can deal it in two ways. One, those R combinations are selections in which this particular person is definitely selected. So, that particular person is definitely selected. So, out of the remaining R minus 1, remaining n, we have to select R minus 1. So, that can be done in NCR minus 1. If that person has to be definitely kept away, so the number of selections would be NCR. So, NCR plus NCR minus 1 would amount to n plus 1 CR. So, this is the combinatorial argument for this Pascal's identity. You can actually directly use the formula here. So, what is it we observe? N plus 1 CR and NCR by NCR plus NCR minus R, one and the same. Therefore, the ratio is 1:1. So, the answer is 1. Let us move on to the next question here. If the middle term of the expansion 1 plus x raised to the power 2n is the greatest term, then x lies between which intervals there? N minus 1 to n, n by n plus 1 to n plus 1 by n, n to n plus 1, n plus 1 by n to n by n plus 1. So, let us have a look at this. Now, 1 plus x raised to the power 2n. How many terms it has? It has 2n plus 1 terms. In a binomial expansion of x plus a power n, we know that there are n plus 1 terms. So, there will be t2n plus 1, 2n plus 1 terms there. When you have odd number of terms, you have a unique middle term. So, what is the unique middle term here? T n plus 1 will be the middle term. This is the middle term. Okay. But what is the middle term in this expansion? So, R is equal to n for you, that is equal to 2n c n x power n. That is the middle term. He says that this is the numerically greatest term. So, what should have happened? Okay. So, that means we would have had something like this. T1, generally the terms will be increasing up to some stage, and then again they decrease. But what we want is Tn plus 1 to be numerically greatest term. So, we want like this, Tn plus 1, and that should be dominating rest of the terms, Tn plus 2, so on, T2n. So, what should have happened? Tn plus 1 by Tn should be greater than 1. Tn plus 1 by Tn should be greater than 1. And also, we need to have Tn plus 2 by Tn plus 1 to be less than 1. So, both these things should be obeyed by our Tn plus 1 if that has to be the greatest term as well. That is of course the middle term. We want that to be the numerically greatest term. So for that to happen, this is what we need. Okay, so what is Tn plus 1? 2n Cn. 2n Cn x power n divided by, what about Tn here? It will be 2n Cn minus 1 x power n minus 1. That should be greater than 1. Okay. And also, what is it you wait? Tn plus 2 will mean 2n C n plus 1 into x power n plus 1 divided by 2n C n x power n. Is a term. That should be less than 1. Now from here, let's observe that, let us look at this. We know this format, we know this formula, NCR by NCR minus 1 is equal to n minus r plus 1 by r. We can repeatedly use that here. Now instead of n we have 2n, and instead of r we have n there. So that makes it 2n minus n plus 1 by n into x, that is greater than 1. So what is this here? N plus 1 by n into x is greater than 1. It means that x should be greater than n by n plus 1. X is greater than n by n plus 1. And from here we will observe that x has to be, from this again applying the same formula, we will find that x has to be in fact less than n plus 1 by n. So from here we will get that x is less than n plus 1 by n. So what does it mean when it comes to x has to obey these two inequalities? What does it mean? X has to be greater than n by n plus 1 and less than n plus 1 by n. Therefore the answer is 2. Let's move to the next question. The coefficients of x power 16 and x power 17 in the expansion a plus bx raised to the power 101 are equal. If a and b are natural numbers, then the least possible value of a is, first option 1, second option 3, third option 5, fourth option 7. Okay. A plus bx raised to the power 101. That is sigma r ranging from 0 to 101. 101 CR a power 101 minus r into bx raised to the power r. Now the coefficient of x power 16, how do I pick up the coefficient of x power 16 here? So r has to be 16 here. Okay, so put r equal to 16. If I take r to be 16, what is it I get? 101 C16 into a power 101 minus 16, how much is that? 85 into b power 16. That's the coefficient of x power 16 in this expansion. And what is the coefficient of x power 17? So what I need to do is I just have to replace r by 17 there. So that makes it 101 C17 into a power 84 now and b power 17. Okay. Now these two are equal. That's what is given to us. He says these two, the coefficients of these two, x power 16 and x power 17 are given to be equal. So what we have here is 1 divided by the other has to be equal to 1. So I'll go for 101 C17 into a power 84 b power 17 divided by 101 C16 a power 85 b power 16, that should be equal to 1. The quotient, the two numbers are equal, therefore the quotient should be equal to 1 there. Now we have a formula for NCR by NCR minus 1. So what is that? Let's recall again. What is NCR by NCR minus 1? Divided by NCR minus 1 is equal to N minus R plus 1 by R. So in place of N we have 101 and in place of R we have 17. Therefore, what do we have? 101 minus 17 plus 1 by 17 is 101. C 17 by 101, C 16. So we have that. And what do we have here? B by A. That is equal to 1 there. What does this come out to be? 102 minus 17. That makes it 85 by 17. 85 by 17 into B by A or A by B. This is what you have here. Is A by B. What is that? 5 there. We are interested, so A has to be a multiple of 5 there. 5 into B. And he says A and B are natural numbers. So clearly A has to be a natural number multiple of 5. Okay, what is the least value of A then? 5 into 1. So if I take B to be 1, take B as 1, then you get the least value for A. So what is the least value for A? A is 5 there. And here clearly the option is, answer is 3. So let's move on to the next question. We are interested in the coefficient of x power 10 in 1 plus 2x power 4 into 1 minus x raised to the power 8 is minus 56, 56, 112, 1 minus of 112. These are the 4 options. Now we have a product of 2 expansions here. 1 plus 2x power 4 into 1 minus x power 8. Now observe that this second expansion has terms starting from x power 0 to x power 8. We are interested in x power 10 term. How do you get that x power 10 term from here? Now there are only two possible terms that you can take from this expansion. So either you take x power 0. Now if you take x power 0 term in this, we need to take x power 10. But do we have x power 10? The highest power of x that appears here is x power 8 only. So this combination is not possible. The reason is, if you took an x power 0 term here, in order to get the x power 10 in the product, we need x power 10 in the second expansion. But x power 10 term doesn't appear in this expansion. What is the highest power of x that appears in the second expansion? It's only x power 8 there. So we can't take this combination. So what is the other combination we can take? Now what is the other term that is left over here? So you can use the x power 4 term, but that x power 4 term comes with a coefficient. So we have 2 into x power 4. And now when I am picking up x power 4 term, what should I pick up from here? X power 6 in order to make the term to be of x power 10. So what is that x power 6 term? What coefficient will that come with? It comes with 8c6 into, again x is not with, it is with the symbol minus 1. So I should take a minus 1 power 6 there. Okay, so that comes out to me. Now I just multiply here. What will be the coefficient here? Now the coefficient will be 2 into 8c6. But 8c6 we know is same as 8c2. So 8c2 we can write it. The convenience is, why did we change it to 8c2? Because it's easy to compute out here. 8c2 and 8c6. What is 8c2? It is 8 into 8 minus 1 by 2 factorial. So I want you to bear one thing in mind here. Whenever you are to compute NCR, it is like this. From n, start writing r consecutive numbers. n, n minus 1, so on up to n minus r minus 1. Start writing product of r consecutive numbers from here. And then you start writing in the denominator r consecutive numbers starting from r. So r into r minus 1 into so on up to 1, which is nothing but the r factorial. So how do you compute NCR? NCR is computed this way. That is, you take the product of r consecutive integers starting from n. Go on. So why am I stopping it? There is an r minus 1 bar bracket here. Okay, you're starting from n minus 0, n minus 1, going on up to n minus r minus 1. That makes it how many terms there? R terms in the numerator, and we have r terms starting from r to going up to 1 there. That makes it r there. So NCR is computed that way. So that makes it 8C2. So what should I write? 8 into 8 minus 1, consecutive 2 terms there. Okay, in the descending order. And then what do we have? So this is 4 into 7, that is 28. Now that is 28. 8C2 is 28, and you have a 2 multiplying here. So what do we have here? 28 into 2. What you want is 2 into 8C2, so that makes it 2 into this, that is 56. So clearly the option is 2. Answer is 2. So let's move on to the next question here. Question number 15. If n is greater than or equal to 2, then 3 into NC1 minus 4 into NC2 plus 5 into NC3, so on and so forth, plus minus 1 raised to the power n minus 1 into n plus 2 times NCN is equal to minus 1, 2, minus 2 or 1. Now, it is to be understood that whenever simply CR is represented and n is playing a role here, then CR is actually abbreviation for NCR. CR is an abbreviation for NCR there. So here, now what you have is 3 into C1 means NC1 minus 4 into NC2 plus 5 into NC3, so on and so forth. The terms will go on like this. When you have NCN, what is it you observe? When you have 3 here, you have a 5. When you have a 2 here, we have a 4 as a coefficient here. So when you have a n here, what should be the coefficient that we have to multiply with? N plus 2. And you observe there is an alternating sign pattern, that is starting from 1 with a plus sign. Okay, so when you have n here, 1 here, you have plus sign. So minus 1 power 0. When you have 2, we have a minus sign. Minus 1 power 2 minus 1. So that makes it. So what should be the sign here? The sign that we need to take here is minus 1 raised to the power n minus 1. So that matches with what is given there. Now into NCN. Okay, what is this equal to? Here there is one important result that comes up. You have A into NC naught minus A plus D into NC1 plus A plus 2D into NC2, that is alternating sign pattern, so on and so forth. Okay, A plus ND into NCN multiplied with minus 1 power n here is equal to 0. This is a result, an important result that has to be borne in mind. This is a result, that is, you see that the coefficient that are multiplying the binomial coefficients, that numbers which are multiplying the binomial coefficients are in AP. A plus D, A plus 2D, these are in AP. And there is an alternating sign pattern attached to this binomial coefficients. NC naught is coming with a plus sign. So when you have a 0, that is even, you have a plus sign. When you have an odd suffix, we have a minus sign. So when you have a suffix as n, it should be minus 1 power n there. A plus ND into NCN. This is known to be 0. Okay. Now, can I use this here? Do you see that these terms are in AP 3, 4, 5, so on? These are clearly in AP with the common difference as 1 there. Okay. So, but we are missing out one term. What is the term that is missing out? NC naught is missing out here. Now this must have been A plus D then, into A plus D is 3. And what is the common ratio? Common difference. Common difference is 1. So A plus D is 3 for you and D is 1. So what should have been A? 2. Had we started the series with 2 into NC naught, then the sum would have been 0. So what is it? We can say 2 into NC naught minus 3 into NC1 plus 4 into NC2, so on and so forth. Okay, all that would have been equal to 0. This would have been 0. Now what you have is this part. Okay, what do we have? We have from here 3 into NC1 minus 4 into NC2. So we will pick all these terms and bring them to the right side, take them to the right side. So what do we have then? So 2 into NC naught is equal to 3 into NC1 minus 4 into NC2 plus 5 into NC3, so on and so forth. All these terms that you wanted here will come here. Okay, but what is this NC naught? That's clearly 1, so 2 into 1. So this entire expression is equal to 2. So clearly the answer is 2. Answer is 2 and the option is also 2 there. Second option is carrying that answer. Answer is 2. Let's move on to the next question. Question number 16. 2 into NC naught plus 2 square into NC1 by 2, 2 cube into NC2 by 3, so on and so forth. 2 power of n plus 1 into NCn by n plus 1 is equal to, first option, 3 power n plus 1 minus 1 by 2 into n plus 1. Second option, 3 power of n plus 1 minus 1 by n plus 1. Third option, 3 power n minus 1 by n plus 1. Fourth option, 3 power n plus 1 by n plus 1. Now, let us consider the expansion 1 plus x power n. You know, this has ascending powers of x, nc naught plus nc1x plus nc2 into x square, so on, ncn into x power n. Now what if I integrate this within the limits? If I integrate this within the limits 0 to x, what do I get? 1 plus x power n, let's integrate it within the limits. Both sides, let's have an integral. What do we get? nc naught into integral of 1 is x, so we'll have x plus nc1 into x square by 2 plus nc2 into x cube by 3, so on and so forth, ncn into x power n plus 1 by n plus 1. There. Within the limits 0 to x. When you apply the upper limit, I get this expansion itself, and when I put the lower limit, since each term carries an x symbol, so all the terms will be going to 0. So upper limit minus the lower limit value, that gives me the same thing. So I don't need to actually carry this. It is understood that I will be getting this expression only. Okay, now coming to the left hand side, what do I have? 1 plus x raised to the power n plus 1 by n plus 1, but within the limit 0 to x. Okay, is all this expansion nc naught into x plus nc1 into x square by 2 plus nc2 into x cube by 3, so on and so forth, ncn into x power n plus 1 by n plus 1. Okay. Now observe that what we wanted was that expression was carrying nc naught into 2, nc1 into 2 square by 2, nc2 into 2 cube by 3, so on. So what should I do? this is an identity, these two are equal for all x. So what I do is put x equal to 2 both sides. Putting x equal to 2 both sides. What do we have in this? Actually, if you look at the left hand side, it is coming out to be 1 plus x to the power, in place of x I put x only, 1 plus x to the power n plus 1 by n plus 1 minus the lower limit value. What is the lower limit value? 1 plus 0 power n plus 1 by n plus 1. So that comes out to be 1 plus x to the power n plus 1 minus 1 by n plus 1 is the left hand side. I am to put x equal to 2 in this and x equal to 2 in this. When I put x equal to 2, I get the expansion that we required. What is the expansion we have? nc naught into 2, put x equal to 2 here. Okay, so we have nc naught into 2 plus nc1 into 2 square by 2, so on so forth, nc2 into 2 cube by 3, and what all that we required there, we are getting that. And what do we have here? I need to put x equal to 2 here. So replace x by 2 here. So what do we get? Replacing x by 2, x equal to 2, when you put, you get 3 power n plus 1 minus 1, 3 power n plus 1 minus 1 by n plus 1. So clearly, we observe that the option is 2. Answer is 2 there. Okay, let's move on to the next question. If n is an even integer, 1 by 1 into n minus 1 factorial plus 1 by 3 factorial into n minus 3 factorial plus 1 by 5 factorial into n minus 5 factorial, so on up to 1 by n minus 1 factorial into 1 is equal to 2 power n by n factorial. Second option, 2 power n by n minus 1 factorial. Third option, 2 power of n minus 1 by n factorial. Fourth option, 2 power of n minus 1 by n minus 1 factorial. Now, observe that we have 1 by, we can read this first term as 1 by 1 factorial into n minus 1 factorial plus 1 by 3 factorial into n minus 3 factorial, 1 by 5 factorial into n minus 5 factorial, so on and so forth. 1 by n minus 1 factorial into 1 factorial. Okay. Let's multiply and divide by n factorial. Multiply and divide by n factorial. Multiply by n factorial and divide by n factorial. Dividing by n factorial. So what if I multiply and divide? I'll multiply inside to each term and divide it outside here. So 1 by n factorial into, what is it you have? N factorial by 1 factorial into n minus 1 factorial plus n factorial by 3 factorial into n minus 3 factorial and n factorial by 5 factorial into n minus 5 factorial, so on and so forth. N factorial by n minus 1 factorial into 1 factorial. What is this? This is clearly NC1, because n factorial by r factorial into n minus r factorial is NCR, we know. So this is NC1. What about this? Is NC3. What about this? NC5. Okay, what about the last one? NC n minus 1. Now let us take for an illustration n to be equal to say 6. What are the binomial coefficients that we come across? That is 6C0, 6C1, 6C2, 6C3, 6C4, 6C5 and 6C6. 66 there. Now we are listing out only the odd suffixed binomial coefficients. 6C1, 6C3, 6C5. So this 5 happens to be 6 minus 1. So we are listing out from NC1, NC3, so on up to NC n minus 1. That will be the last binomial coefficient with odd suffix here. So we know that sum of the binomial coefficients with even suffixes is equal to sum of the binomial coefficients with odd suffixes, and each is equal to 2 raised to the power n minus 1, because we know that sum of all the binomial coefficients in the expansion is 2 power of n, and odd suffixed binomial coefficient sum is equal to even suffixed binomial coefficient sum. So when you have each should be half of 2 power n, that makes it 2 power of n minus 1. But we have a n factorial that is dividing here outside. So this is finally, what is it? This entire expression which is inside the bracket, we are going to see that it is 2 power n minus 1, and replacing it by 2 power n minus 1. Finally, the answer is 2 power n minus 1 by n factorial. And that's clearly present in the option 3 there, answer 3.